Hi everyone. Today we're going to be talking about how to access databases with programming languages. So up to now in this course we've been talking a lot about databases, which is different than what you've seen up to now with in terms of computer science classes. The difference is we're going to want to take these languages, Python, Java, C++, any of those languages, and use them as an interface into whatever database you have. So for this course, we're going to use Python as a demonstration because it's convenient and because in subsequent courses for this degree, you're going to need to be using Python for accessing databases. So this is really a foundation for what you'll be doing later on. So Python has something called a database API, and the designers of Python decided that rather than build support for individual databases, variants of SQL, for NoSQL databases, all these things, rather than build individualized packages, they decided that it'd be better to come up with this API which specifies the interface where all database modules must adhere to in order to access the database from Python. So in good computer science fashion, we have a modular solution where the interface specifies how individual databases can be accessed from Python without actually specifying how that interface must be implemented. So the reason for doing this is to make your code that you might write in Python reusable, so that code you write in Python that would access a MySQL database could also potentially be used to access a PostgreSQL, SQLite database, perhaps even a NoSQL database. So it's actually pretty great. If you want to learn more about it, you can look at this URL here on the python.org website, which gives all the gory details of the API spec. Today, we're just going to go through some examples explaining how to basically use the Python database API and to get you up to speed on how that works. So, because we have this database interface, if we want to use an example, we need some kind of actual SQL like language in order to interface directly to Python. And so you can pick any database you'd like, but the easiest choice is something called SQLite. So that's what we're going to use. And the reason why SQLite's a good choice for us is because it's a disk-based implementation of a database. So it doesn't require that you're running a separate server-based process for the database, so there's a lot less overhead in setting them up. And in fact, there's built-in support for SQLite in Python, so you don't need to install any additional software to actually run this. All you have to do is run some Python code and you're good to go. SQLite is quite popular for prototyping databases, and it can also be used quite frequently for local data stores. So if you are implementing some software that needs to have a local, relatively small database that has low overhead, SQLite can be a good choice, and so it's often used in professional applications for that. So we're going to use SQLite, but most everything I'm talking about applies in general to whatever database you're going to be using. So the key thing that we need to know about for accessing databases using the database API are two classes of objects: connections and cursors. So a connection object is one which is used to access your database. So you have a database that exists somewhere on your computer or on a server, and you want to be able to access that database. So that's what connection objects are for. Once you've actually set up that connection, the next step is use a cursor object. We'll actually then execute queries. In fact, the command for the method that will implement the query execution is called execute. Once you've executed the query, the next thing you can do is you want to fetch the results. So if you're doing, you have several choices for that. You can just do a fetch one, which will give you the first available result. Fetch many, where you can specify exactly how many results you want, or just get them all by using the fetch all command. If you manipulate the database, inserting new entries, for example, you want to be sure to call the commit method in order to actually commit those changes and write that to the database. So that's in general how it works. How might this actually look in practice? So we've got a bit of code here on the screen, and the first thing you'll note is we have to actually import the SQLite 3 package. So that's Python's implementation of the interface to the SQLite databases. And that's standard in all versions of Python that are very relatively recent. So then you have this next line where you actually are building the connection object. So that's the SQLite3.connect command. So in the simple case, we're just connecting to this database without any username or password. So once you have that, there's more rigmarole you have to go through. So you set up the connection, but then you have to also establish this thing called a cursor. So a cursor is an object which is associated with the connection object. So you've connected to your database, and you get a cursor, and that cursor is what allows you to then execute queries and do things like inserting things into objects. So that's once we've actually established this cursor, we're going to store that into a variable named C, and then we have a series of things that you've already seen in this class. SQL commands. So C.execute that first one will actually create our table. So what's passed in here is a string. So the way Python deals with executing SQL statements is you call this execute method and apply a string with whatever the SQL command happens to be. So we first create this table. For this example, we're going to track stock transactions. So we build the table, and you can see this is all just SQLite syntax. We're saying a data object, it's a text, transaction type, the symbol we're buying, price, and so forth. So we build the table, then we just insert some values into the database. And so that's all well and good. But the last step you have to remember to do is once you've done that, if you actually want your database to remember, you need to run this commit method. And now notice we're back to executing the commit method for the connection object, not the cursor. So the cursor object is used to actually execute commands, but doing things like committing, opening, and closing the database access is all done through connection objects. So there you have it. Having seen how Python works from earlier in the course, and now having seen how to construct these statements, it's actually pretty straightforward to then just use this API to access these commands. So one last thing we might point out here is let's say rather than trying to insert into the database like in the previous example, we're trying to run a select query where what comes back are query results. And so if we do that, we still create our cursor just as before, and we execute the statement. But now we're actually using these fetch commands. So now we're saying just fetch one result that matches the previous executed query. So the SQL statement is familiar, where you say give me all the results where the stock symbol is Google, and then we can call this fetch one method. Now notice one little quirk of Python is that you need to actually print out the output. So this fetch one method actually returns a query result set object, and so that doesn't actually print nicely to the screen. So what you need to do instead is actually print the result, and it will look nicely rendered as this tuple here. We have a 5-element tuple with basically corresponding to a row in the database. All right, so we have now used connection objects to connect to the database, cursors to execute queries, committing our results, and then fetching them as well. So having given you an example, I want to actually talk a bit more about in greater detail about how some of these methods work and the objects themselves. So the examples I've shown you, when you use the connect method, the only parameter we're using is this DSN parameter, which is the name of the data source, the location of your file. That in fact is the only parameter you need to include. But if you have a database that's password protected, for instance, you want to actually provide those credentials at this point as arguments to this connect method. So you can use the username and password, and you can also specify the database name if you have multiple databases that you're trying to connect to. So there are some additional methods to the connection object worth discussing. So we've already seen close, which is what you do when you don't want to use the connection of the cursor anymore. Commit, you've seen too, which is going to put all committing transactions in. Now, one thing I should say is that we're dealing with this Python database API interface. It's an interface, and depending on your implementation, some of these methods are not supported. So commit is not always supported. So you want to check with the particular implementations. It is supported for SQLite 3, but for other versions maybe not. So that's just a word of warning. Then we have the cursor method, which returns the cursor object that allows us to execute queries. And lastly, we have this other optionally supported method called rollback, which will throw away the results of the uncommitted transactions. But this may or may not be implemented. Usually is, but you want to double check your particular module. Okay, so the last thing we'll talk about is the methods that are associated with cursor objects. So many of these you've also seen before. So you can close a cursor, much like you would close a connection, but you want to do this perhaps in cases where you want to keep the connection to the database open, but close out the cursor. This can be used sometimes to improve the efficiency of your accesses. Then we have a few variations on execute and fetch methods. So we've already seen the standard execute method, which will execute a single statement that you provide. You also have the option, however, of executing multiple statements at once, where the only thing you vary is the input parameters that are provided to the operation. So that's the execute mini method. Then the last grouping here are the fetch methods. So we have fetch one, which will just give you the next available query result. But you can also specify exactly how many you'd like using fetch many, where you pass along the number of results you'd like to have. And finally, you can take the whole shebang and fetch them all using the fetch all method. So that wraps up this session. What we've covered here is how to access databases using Python using the magic of the Python DB API. Today we're going to talk about doing work with databases in Python. So we've already seen how to actually access a database using Python via the Python DB API, but now I want to show you some examples of how we might want to dig in a bit deeper and use the best of both worlds, the best of Python and the best of your database access language like SQL. So why would we want to mix these? Well, SQL, NoSQL, all these query languages that you're learning about in this class, they're great. And they're great whenever you need to access a data store. But they're somewhat restrictive, especially if you want to do things besides what they allow in terms of querying and inserting into that database. So if you want to manipulate the results in a particular way, then you need the power of a general purpose programming language. And so writing code that actually works with the database can be a lot more convenient. And so what we're going to talk about today are some of the built-in tricks to the Python database API, which makes coding in Python while accessing databases an attractive and compelling thing to do. So first thing we'll discuss is how you can use iterators instead of the fetch one method to get a series of results from a database query. So recall from your earlier discussions of Python that you actually have this weird way of accessing for loops. So we have these things called iterators in Python, where you will say for a given local variable name in this iterator object. And so if you supply a list of values into a for loop, the iterator will return in sequence each value from that list. And it ends up making these nice, convenient ways of writing for loops. For those of you who are familiar with languages like C and C++ and Java, the Python for loop is much, much more elegant. So, but we'd like to be able to take advantage of that using the Python database API. So what we can do is we can note that the execute method actually will sometimes return values that have iterators associated with them. So this first example I'm showing here in option 1 shows that if you say for row and c.execute, and you have your statement, your select statement that's going to get some values back. What it will do is it will one by one return that value and assign it to the value of row. So if we just very simply print out that value of row each step, what do we get? We get a sequence of return values from the iterator. So that's pretty nice. So by doing this, you no longer have to actually use the fetch all command at all. So for those of you who have grown used to fetch all and always having the sequence of executing your commands and fetching the results, you never fear, you can still do that. So the option 2 is still available, where you execute the query and then you use the fetch all method inside your for loop. So you say for row and c.fetch all, and it's going to return an iterator that's going to give you each of those values as you go through them. So either way, it's fine. But the more Pythonic way to access these values would be using option 1. So another very common use case for when you're working with a high-level programming language that's accessing a database is that you may want to assign certain variables and use those variables as input into your database queries. And this is a perfectly good thing to do. It's very, very common that you want to do it, but you have to be careful with what you do, because there are some serious security implications for how it is constructed. So if you take the naive approach, you may end up writing insecure code that could be hacked to reveal information stored in a database that shouldn't be revealed, or even to manipulate a database in a way that it shouldn't be manipulated. So let's look at this first example code here. It seems seemingly innocuous enough. So let's say we wanted to query our table of stock transactions, and we wanted to have a select statement that was going to give me all the transactions that involve a given stock ticker symbol. Okay, so say the symbol of Google, G-O-O-G. So we might store that as a variable called symbol, and then execute the statement as follows, where we say we have select star from stocks where symbol equals, and then we use this %s, which is string formatting. Which is common in Python and other high-level languages. And then you pass that actual variable into the statement. So if you were to execute the statement, it would work, it would give you the answer you expect, and that would be fine. However, this is a very dangerous thing to do. And so what's wrong with doing this? What's wrong with inserting a string like this into an SQL query? Well, the best way to see that is to read this comic. So this is a classic XKCD comic, so bear with me, I'll actually read it to you. So hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert, quote, parentheses, semicolon, drop table student, semicolon? Oh, yes, little Bobby Tables, we call him. Well, we've lost this year's student records. I hope you're happy. And I hope you learn to sanitize your database input. So this example here shows what can go wrong if you allow arbitrary strings to be included in a SQL or other database query. So you might think, in your like the previous example, that all you were doing was expecting a stock ticker symbol to complete that transaction. And if the input transaction is well formed, that's all you'll get. But a malicious actor might come in and actually try to insert some code like this, where you would then gain further access, execute additional queries. And so this is a big problem. So what can we do about this? How can we be safer? Well, what you can do is you can use something called a SQL placeholder. So this is an example of that code here. So we can see that what we've done is we still have our string Google, but now we're representing it using a tuple. Okay, so that's why we have the parentheses around it. And the comma is also important. So we're representing it as a tuple that is precisely one element long. So we then will execute the command just as we did before. So, but if you look at the command now, we say select star from stocks where symbol equals question mark. So question mark is that SQL placeholder. And now we supply a second argument, which is the parameter that we're trying to execute. Okay, so you run this, and then you print the results, and life is good. You get the right answer, and you will have prevented Bobby Tables from ruining your day. So these placeholders are useful because they separate out the actual query that you specify with the data and input parameters that you provide. So now we have two arguments to the execute command, and by keeping those separated, we can actually successfully prevent the addition of database commands when they're not welcome. So why are they safer? Yeah, it's because you have the separation between parameter values and queries. And it also enables the user to restrict exactly what the query can do. So you're saying, I only expect input data in this one particular part of the SQL statement. You don't expect that input was going to allow additional information, additional queries to be run apart from what's stated there. There are some idiosyncrasies in making this work. Like I said, placeholders have to be transmitted as a tuple. If you tried to execute that statement I just showed you, where you treat that value as a string and not a tuple, you're going to get an error. And this is all done to try to enforce the restrictions on the types of data that can be supplied. The last thing I'll say is that for SQLite3, the placeholder is a question mark. It's not always a question mark. It can be something else. Another common use is the placeholder :1. You'll need to check the particular implementation for the database that you're using to be sure. So let me give you one more example here of how you could use an SQL placeholder. Here we have a list of transactions that we want to add. So let's say we want to buy some Amazon stock, Microsoft, and IBM, and sell our IBM stock. So we can first create a list of tuples, and then we run this execute mini command where we say, all right, we expect that there's going to be supplied tuples that have 5 elements in each, and so we insert them into the stocks table as specified in the statement. And then we supply this argument, which is the list of these tuples. So that shows you how to execute transactions safely, but still use variables when you're doing so. Okay, so the last thing we're going to talk about today is using Python scripts to create a more user-friendly interface to databases. So not everybody is going to know how to write SQL. They won't have had the fortune of taking this course. And so what you'd like to be able to do is you'd like to be able to still actually run these SQL queries, but do so in a way that allows non-experts to provide inputs, and then allows you as a programmer to create the appropriate corresponding query, and then present the results in a user-friendly way. So the way we can do this most simply is to write some command line Python scripts that accept arguments from the user. So I'll start with an example here, a very simple example we'll call it gettxdates.py, where what we're trying to do is back to our stock market example, and we want to select all of the transactions that occur on a given day. And so to do that, we want to allow the user to actually specify which day we're going to get the transactions for. So our code starts off like we've seen before. We are importing SQLite, but we also have to import sys, which is the package which allows us to actually access command line arguments. Everything else is the same, though. So we have our connection to the database, we have our cursor that we build, and then we have our query. Our query in this case selects star from stocks where date equals question mark. So we're being safe here using the placeholder. So we're going to allow the user to specify what that date should be. So we then execute this query, and we're going to execute it inside the for loop. We say c.execute query, and then we have the sys.argv1. So this is saying that the first provided parameter at the command line is going to be the query that we execute. In order to make this actually work, we need to represent it as a tuple. So that's why it's wrapped in these parentheses and has the trailing comma at the end. But once we've done this, this is now much safer than if we were to just allow an arbitrary string to be specified by the user. So we execute the query, and then the rest of this for loop sort of steps through each of the transactions that match the query. And we use some string formatting to make the results presented to the user in a more intelligent way. Because if we didn't do that, then all we'd be doing is printing the results of the tuple. And if the user, again, wouldn't necessarily know what each row in the database is. And so we need to actually make it more digestible for them. So that's exactly what we've done. And once you've done that, you actually execute the script. And at the very bottom of the slide here, you can see what happens if you were to invoke this at the command line, say Python gettxdates.py, and then say for December 1st, 2014, tell me all the transactions that were sold, bought or sold. So we have 10 shares of Apple, which were bought at 115.58 each. Total value is 1155.80. And 50 shares of Google sold at 532.58 each. Total value 26,629. So that looks nice. And you can see we're actually taking advantage of the fact that we can do nice things in Python. So we were able to combine the results for the share price and the number of shares to say what the total value was that was bought or sold. This is just a very simple example of how you might try to build an interface using Python to actually access your database. So that wraps up what we've covered in this talk today. We have, to recall, we have covered, number one, how you can use iterators to access queries using for loops. We've talked about the importance of using question marks in these placeholders for SQL queries to make sure that Bobby tables is kept at bay. And we've talked about how you can build scripts that provide nice front ends for non-SQL conversant users to interact with your database. Okay, so today we're going to talk about how we can use Python to help grab data from an external source, process it as necessary, and then put it into an existing database. So essentially, what we often have to do is load comma-separated files into a database. That's a very common task. So there's data all over the internet right now. So there are lots of websites where you can download giant tables, spreadsheets, flat files, anywhere you want. And so places like data.gov track government sources of data, and each of these sources is potentially very useful for those of you who are trying to do some science on the data that you collect, but you need to have an efficient way to take the data in whatever form it comes in and put it into a database that you can manipulate and work with. So that's what we're going to talk about today. So we'll focus first on the case of these comma-separated files because this is the most common format for files. And we'll use that as a demonstration of what's possible using Python. And the same skills can apply in other circumstances. So Python has a package called CSV, which actually supports a lot of the functionality that you need for reading and writing from CSV files. It handles useful cases such as particular delimiters, so you might have a separator that's a tab or a comma or a semicolon or an ampersand, who knows what. But whatever that is, Python can deal with that, and also the many different ways in which characters are quoted. So we're only going to scratch the surface here and go through an example. For full details, you can visit the URL on your screen. The example I've selected for demonstration today comes from data.gov. It's a list of banks that have failed according to the FDIC. So these are banks which have had to shut down due to lack of funds or liquidity or whatever, but these are all made available online so you can track them and see where this is happening. Unfortunately, at SMU, we don't make a public database of failed students, so no matter how things turn out in this class, you're going to be fine. You don't have to worry about parsing that CSV, but same principle applies. So if we look closer at this data, we can see that we've got several categories. We've got the name of the bank, city, so forth, something called CERT, which is the identifier the FDIC uses, acquiring institution, closing date, and updated date, excuse me. So if we kind of look in here, we can sort of see that the separator file likely is this comma, so that's pretty good. But you'll notice that in some cases we have quotes, in other cases we don't. So the first bank listed is Frontier Bank, comma, FSB DBA El Paso Bank. With a name like that, why wouldn't it fail? But that entire entry is separated by quotes, which is created there because there is a comma in the name. So that's a way for CSV files to indicate that this entire string is actually one entry. But you look in the next row, the National Republic Bank of Chicago, because there's no comma, there are no quotes. So we have this mixture of some rows quoted, some rows not. Which can actually be cause a bit of a headache if you're just importing this naively. Fortunately, this is the very sorts of thing that the CSV package can deal with nicely. So what would we do to make that work? Well, the first step, and this is a bit of a review from the previous sessions, we are going to need to create a table using Python. So we're going to use our connection object to connect to a database. We're going to create this database called failedbanks.db. Then we are going to create a cursor, which allows us to execute statements on that database. So the first statement we're going to execute is this create table statement, which has for each column in the table an appropriate name and the type. So we've got, most of the types are text except for cert, which is an int, and that also is the primary key for our table. And you'll notice that for the last two entries are closed and updated. Those are actually dates, but for simplicity, we're going to start by just treating those as text. I'll show you at the end how you could actually treat that as a separate date object. Requires a bit more work, though. Okay, so what do we then do? Well, we construct our query that we want to insert into the banks those values. They get imported from the CSV. Because there are 7 different columns, in each row, we have 7 question marks in the query statement. Remember, those are SQL placeholders. We use those question marks to be more secure. Then we import the CSV package. We're also going to import URL-lib, which is a Python package that allows you to download URLs. This is going to come in handy if you're trying to access online data sets, that's where you have the CSV that's been posted on our website. You want to be able to download that and open that locally. You can use this URL open method in the URL-lib package, which is what we're doing here. We're opening the CSV file that's placed on the FDIC's website. So the first thing we do is we actually open that, and that returns a file reader object, and then the magic happens here in the for loop statement. So what we're doing is we want to go through row by row from the CSV file. So we use something called the CSV.reader method. And the CSV.reader method expects a few things. It's first going to expect a file object that has a CSV file in it. That's what the CSV file variable indicates. It also takes a bunch of parameters. The 2 key ones are the delimiter and the quote character. So delimiter expresses the delimiter that's required. In this case, it's a simple comma, but it could be a tab, it could be anything. And then the quote character indicates how it should deal with quoted entries. And so because we noticed when I looked at that sample data, we actually had some quotes in there. It was a double quote, so that's what we indicate with the quote character. So the CSV.reader method returns an iterator, which is why we can use it in the for loop. And going through there, we are going to go row by row through the CSV file. So the first thing we have to do is we have to check to make sure that we're not stuck on the very first row of the CSV file, which is a header, indicating the name of each of the columns. We want to skip that. We don't want to put the header into the database, so we have this if statement. We say if the first element in the row list is bank name, which is the name of the first row column, or the name of the first column of the CSV file, then we're going to skip it and move on. So that's what that first line indicates. Then we have to do a little bit of cleanup so that the third entry in the row really is the certification number, which is an integer. So we need to actually convert that from a string into an integer, which is what we do in the next row in the for loop. Then we're all ready to go, and we just execute the statement with the query we've already prepared and the data, which just happens to be the row. And we just keep going through that for loop until we reach the end of the file, and then we stop. We commit our results, and then we close. So that's how you do it. That's how, if you have a nicely formed CSV file, you can take the CSV file and put it into a database using Python. So you'll notice that there are some interesting things when we go back and take a second look at this data set. We had the comma separating things, and we had these quote characters. Well, we need to be aware of the 2 parameters inside the reader method. The delimiter, which is a single character string indicating how you separate the values, and then quote char, which is going to is a little bit fancier, but it's going to tell us if we're using these double quotes or single quotes, whatever we're using to quote entries that may have special characters inside them. So this is whenever you have things like whatever your delimiter is, so in this case a comma. If you have quote characters actually inside the entry, then you need to have those need to be escaped with quotes, or if you actually have the line terminators like new lines in there. So in our case, it was a double quote, this FDIC data set, but it could be anything. And Python lets you specify. The other thing I want to talk about is how we deal with date information as it comes in, because dates are really special data types. They're not quite numbers, but they're not quite strings either. So you can interpret them as text, but that would undermine the fact that there are differences in dates. So you can actually compare when one date comes before another. And so most of the time, most databases will have a separate object type or data type for dates. And we can actually read into our database date entries and put them into our database as date objects. But to do that, we have a little bit of additional work to do. We will take advantage of the Python date and datetime objects. And these are sort of built-in objects of Python, which keep track of things like the day, month, year, time, all that stuff. They have some additional methods that are of use to us. One is called strp time. What that does is convert a string, which is what your data usually comes in as, and turns it into one of these date time objects. And the trouble with dates is that everybody has a different way of encoding them. And so Python, in this date time module, has ways that you can actually deal with many different formats that dates come in. If you go to the URL in the slides, you'll see a very nice long table that explains all the many different formats for dates, months, years, and so forth. There's a corresponding strf time method, which will go in the other direction. It will take an existing date time object and turn it back into a string. So let's put this to work for our FDIC data. So what we're going to do differently than before is we have changed the table we're going to make, and that table now has, for the closed and updated columns, those are now date objects rather than text. But to actually make that work, we have to look at the data that we have here and look at those dates. It's kind of in a strange format. So we have the day in numbers, dash, an abbreviation of the month, 3-letter abbreviation of the month, dash, and 2 digits of the year. Okay, so this could be a real bear to parse if you don't have the support of a package like Python's datetime system. For example, dates. Dates that begin with, that don't have a trailing 0 could cause problems. So, the 30th of May is just fine. But if you look at the top row, the Frontier Bank actually closed on the 7th of November. And as a result, you have this no trailing or no leading 0 there, which makes parsing this much more difficult. But if we go back and look at our trusty table of format characters from the Python website I just referenced, you can identify this particular pattern and parse the incoming text accordingly. And that's what we're going to do in this little bit of code here. So this code looks very similar to what I've shown you before. We have our query strings going to insert into banks each row. We open up the CSV file from the FDIC's website. But inside the for loop, a few things have changed. We now now have this the statement that begins row -2. What that's saying is we need to update the value that's the second to last entry in the row tuple to now become a date. And so we use that using the datetime.strp time method, where we first supply the string and then we supply the formatting. So in this case, it's %d-%b-%y. And you'll have to trust me, or you can pause this and go check the table and see what each of those format values correspond to. And you'll see that the %d corresponds to numerical representation of the date. %b is the three-letter approximation of the month. And not only in English, it's also programmed for most major languages. And %y is the two-digit year. So you get that all in there, and you have a nicely formatted date. You can then insert that into your database, and now you're free to issue all sorts of queries on the values that are different for dates. So I will wrap up by just saying that Python is a really great tool for working with messy data. So we've shown some relatively well-behaved data, but even so, there are issues about how to deal with quotes and delimiters and whatnot, and the CSV package is really great. So whenever you need to clean the data, you're much better off using a language like Python and its built-in tools to help parse things out. So like I just shown you, parsing a custom date format, you don't want to be doing that manually. And for more examples, I'll refer you to the upcoming screencast, which is going to explain how to clean messy data for different sets of data altogether. Okay, so that wraps up what I'd like to talk to you about today. Thanks.
Hello, so today we're going to talk about how we can use Python to interface with databases using the Python DB API. This screencast is designed to accompany the lectures, where we'll actually be reviewing at first some of the code that was presented in the lectures. We'll run them on the interpreter. So at first, everything you see you have at least heard about in the other video lectures, but today we'll go through them on the interpreter, and we'll build on that with some new code that you haven't seen before to do some more interesting things with the data. Okay, so this is my standard setup for running Python. I'll often have a text editor, in this case Emacs, but use your text editor of choice, where you'll have Python code that you'll want to run, and then I'll have a terminal window where I can actually run Python commands. So if I go ahead and start that on Python on the right, then we can get going. So essentially, we're going to be creating and working with an SQLite database, but this is just for convenience. As a reminder, the Python DB API can work with many different types of databases using this common interface. So we're going to start by doing sort of the necessary details, where we will import the SQLite 3 package, and then we'll connect to an example database. And let's go ahead and give this a new database. We'll call it example new. And the reason I did this is because if that file already exists, then you're going to actually be adding new entries to it. But I want to be sure that we start with a fresh database, so I'm going to give it a new file name that I know we haven't used before. And then I can just copy these first lines into the interpreter, and they run on no feedback, so we didn't do anything interesting. But we can also actually start doing some useful stuff with the database. We can start by creating our table of stocks. That's going to have the date of the transaction, some text of the transaction type. This will be indicating buy or sell, the stock ticker symbol, the amount of shares we want to buy, and the price. So I can execute this to build our table, and what returns from the interpreter is a cursor object saying, yeah, we've done that. And I'm going to go ahead and just insert a couple of lines of code here, where we first execute two statements. So basically inserting new entries into the stocks table, right? So to do that in Python, as a reminder, we actually have to provide these tuples here. So we say, look, it's on December 1st, we might buy 10 shares of Apple at $115 a share, or we then at the same time want to sell Google 50 shares of Google, which trades at a bit more. So I execute both of those statements, that's fine. But as a reminder, to actually make sure that these things run or stored, we need to actually run this commit command. And once we've done that, well, we can carry on if we want to add more entries, or once we know we're done, we'll close the connection. And if you then look and go back to your file system and say example new DB, you see that actually makes this file as an example new DB, which has the information we need. Not very much information. So let me go back to our Python interpreter, and we're going to start a new section where a new set of code. What we're trying to do now is we've got some entries into the database, and we will instead try to access this. So we have to reopen the cursor, and then we're going to execute this command, select star from stocks for symbols Google. So we want to get all of the transactions involving Google, and then that command runs, but to actually then see the result of the select query, you have to run one of these fetch commands. So if we print the results of the c.fetch1, we end up with a tuple that has the transaction that we recently entered. You can see above here, where that's the transaction that we entered before. Then that's fine. Well, let's go ahead while we're at it, insert a few more new transactions to keep things interesting. And if we do that, then we've now got a buy and sell of Facebook and Microsoft, respectively. So now we can discuss a couple of ways that you might try to access a query, access the results of a query, and there's some sort of built-in Python things that will make this easier. So one is to pass this execute command, the results of this execute command, into a for loop. So you will naturally have an iterator that will iterate through the values that match the resulting command you execute. So if we're trying to say, give me all of the transactions, but I want you to order them by price, and then because we just want to print them out, we can have a for loop where we will iterate through all of those values, like so. So if we're row in this execute, so the c.execute function placed in this context is going to return an iterator that will one by one fetch a result and put it into this local variable row, and you can see look one by one they get printed out, and they're printed out in the order in which our query specified. So in this case, the lowest, the highest price of the share. So that's not the only way that we can do this. So that's sort of the nicest way, because you're combining the execution of the command with the for loop. But if you want to do the traditional way, what you can do is you can also just execute a command. In this case, selecting all the stocks, this time we'll change it around, we'll order by the date of the transaction. Then in our for loop, what we do is we just have to go ahead and have this fetch all command, which will actually try to get all of the results that match, and then one by one print them out. So the result ends up being the same, but I prefer the first case because it allows me to execute this in one less line of code, and it's much more Pythonic to take advantage of the iterators built in to these methods. So one of the things that we talked about was how can we then customize transactions, because let's face it, what are the circumstances in which we want to use a high-level language like Python to interact with a database language? Well, what we want to do that is if we want to maybe allow customization of queries. Okay, so one simple customization could be to allow the user to specify what one of the values should take on. So like you could say for our example database, if the user wanted to specify the ticker symbol that they get results for. So the naive way to do this is to just assign the part of the query that you want to specify to a variable, a string variable, and then use string formatting like we're doing here to execute the command where symbol equals and then use %s. So if you run this, print c.fetch1, it's going to work. But just because it works doesn't mean it's a good idea. And the problem is that this is insecure because as we were illustrating in the lecture, that you could have a case where someone might specify a general string that would do more than you expect to, not just providing a symbol, but maybe inserting arbitrary commands. So the way around that is to use one of these symbols here, like in this case the question mark, where you will separate out the statement of the query with the data you're going to provide into the query. So what we have to do is we have to create this tuple, in this case Google, put that in there. So that's what T looks like, and then we can execute a command where we actually specify that what's expected in there actually is just one symbol. So if you tried to actually insert, drop table stocks, semicolon drop table top stocks into that variable, it would not work. So again, we get the same result, but this way it's more secure. Let's go ahead and just execute this next command, which will allow us to execute mini and insert mini values into the database. So if we construct a list of tuples, that's what txns is here. It's a list of tuples. So we have a list indicated by the square brackets, and then each tuple indicated by the round brackets. And you can see we're inserting three transactions: buying Amazon, selling Microsoft, and selling IBM. And then we can provide this list of tuples to an execute mini method. So we give the exact same query string, but now we're providing, instead of providing a single tuple, we're providing a list of tuples, and this is goes to execute mini command, and it basically works. Now we of course need to commit it. Oops, and then now we can see our first example of syntax error, right? So I said c.commit and it didn't work. It says no cursor object has no attribute commit. Well, that's because your instructor is being silly and he tried to commit the cursor rather than the connection object. So we actually have to commit connection and then to the database, and that will execute fine. But this also shows one of the nice uses of the interpreter, is that you get this feedback whenever you screw things up, as inevitably happens. Okay, so that gives us an introduction, step-by-step, in the interpreter, following what we have covered in the video lectures. However, what we're going to talk about now is a new thing. So I want to talk about something we didn't talk about in the lectures, but just to give you an example of how you might then try to use Python in conjunction with querying a database. So we're going to use the same database that we've been working with all along. This example new.db, and what we're going to do now is we want to write a method. We're going to write a method that will give us the total daily transactions. So we're going to allow the user to specify the date that we're interested in. So so things like, as a result of this, you will take the date, and what will come back is a report of the total value of all the transactions that were buy transactions, the total value of all sell transactions, as well as sort of the overall cash balance that you get as a result of that day, whether you bought or sold more items. So what we'll need to do is we'll need to start by constructing a query that will actually allow us to specify what the date should be. And we have this line here, which, as I'm looking, seems to be a little bit insecure, so we need to actually make this more secure. So how do we do that? Well, we get rid of the string formatting, and we end up saying where date equals question mark. Then we supply what we're going to put in our day variable to this tuple here as a second argument to the execute command. So what we have here is a list comprehension. And I'm going to start by kind of running through how we would do this in the interpreter to make sure that it's doing what we expect it to. Then we're going to sort of put it back into a method that a user could invoke. But this sort of reflects a standard programming paradigm that you would use in Python. You sort of start with what you think could work, put it in the interpreter, get some feedback, tweak it, work out any bugs, and then eventually put it back in some code that will actually be reusable by defining a method as appropriate. Okay, so the first line here is a this comprehension, and when I run it, I get an error saying day is not defined. So we'll need to say, okay, let's specify date. Let's pick a date that we know was used, 2014 12:01. Okay, so then now let's try to rerun this, and what do we get? Well, first of all, it works this time. So what's happening is we are executing this cursor object here. We're executing this query for a given day, saying give this to me. But what we're doing is a list comprehension that's going to repeatedly do this until we run out of usable commands. So what actually comes back in transactions? Well, we have two transactions, a buy and a sell, one for Apple and one for Google. And so we have a list of tuples. So that seems to look pretty good. We can sort of go back and look at our prior commands that we executed, and you can see that, yeah, we really only bought and sold things on December 1st. Those are the only two commands. So that's operating as we expect that it should. So that's good. So then what we want to do, what we want to do here is we want to say, okay, give me the sum of the transaction value for all the buy and all the sell transactions. So what we actually need is we need to take the product of these last two values in the tuple, right? So when you're buying 10 shares of Apple at $115, it's going to cost you 10 times $115, right? $1,150. So what we want to do is we want to do that for all the buy transactions. So this is the sort of thing that lends itself well to list comprehension. So we've already got the set of all transactions, the list of all transactions that took place in that day. And what we're going to do now is we're going to try to do another list comprehension where we perform this operation for calculating the product of each value. So we're saying the total bot gets the sum of this list comprehension. So list comprehension is saying that I want the third and fourth value of the tuple and multiply those together for all of the variables in the transactions where we're dealing with buy transactions. So this is an example of a fairly involved list comprehension where we're going through iterating all of the elements in the transactions list, and we're performing an operation, this product on these two values in the tuple. But we're only doing that if the transaction is a buy transaction. So you put all that stuff together, and you end up with something called total bot, which we put in an interpreter that tells us it's 1155.8. Which pretty much makes sense because we only have one buy transaction. It's to buy Apple 10 shares times $115. So that's not too bad. Now you might say to yourself, I think that I want to make sure this will actually work even if I buy additional goods on that day, because so what if it works at list of size 1? For better debugging purposes, you better do more transactions. So let's say we also bought on December 1st, 10 shares of Facebook while it was trading at 74.58. Okay, and then we want to commit that to our database. And now, if we go back and rerun our transactions command, what does it look like? Well, now we have a third entry here. We have a buy of Facebook as expected. So that's good to know that this is all working as we expect. But now if we redefine total bot here as the sum here of all of these transactions, total bot ends up being 1901.60, which sort of makes sense because we have our 1150 for Apple plus another 10 times 74 times $750 for buying Facebook shares. So lo and behold, total bot does seem to be working well. We can do a similar computation for the sell transactions, where again we're taking the product of the price times number of shares times price for all the transactions that are sell transactions. It tells us total sold is $26,000 because we sold 50 Google shares and they were worth a lot more. So if we want to actually print this off in a nice way, we could use a command like this where we say, look, total bought, total sold, cash balance, and we're using string formatting to say we're going to pass in float values for each of these for the shares, the values bought, values sold, cash balance, and so we say the total bought, total sold, and then the cash balance is going to be the difference between the total that you sold that day minus the total that you bought. So we print that out, and voila, we see that because we sold $26,000 worth of stock, even though we bought $1,900, we're still on the day we have a cash balance of almost $25,000. Okay, so now we kind of tried this all out in the interpreter. We see that it works. So then we can go back over to our code here and see how we actually turn this into a usable function. Well, we can have a function called get total daily transactions, where we have a variable that will specify the day and also the database name. But we're going to provide a default parameter for the database name. So in this case, it's example new. So the user can override this if they have a different database they're working with, but if they don't, they'll just work with the one that we know. So we have to provide some of the initial connections to the database inside this method. So we're gonna have a connection that will open the connection to the database and get us a cursor. Then we basically just have all these lines of code here that we've issued in the interpreter. So we assign transactions using that list comprehension. We get the total bought, total sold, and then we print out the results. And in the end, we can even return a tuple with total bought and total sold, so that someone who calls this can work with it. So we have this. We think it works. We're gonna paste it in the interpreter. And so now if I say get total daily tx of December 1st. Voila, we'll get two things. We get printed off this nice formatted string saying what we've seen previously, and it gets returned to us with the bought and sold value. So if we wanted to actually take advantage of that tuple, we could say assign variables here, bought, buy, sell. And then now we actually have variables assigned directly to each of them. So that's nice. Now it's good to see that works. And you want to do some additional checking, right? So let's see what happens if we do this on something we haven't done previously, like December 5th. Okay, well, it turns out on December 5th, we bought $3,300 worth and sold $2,917, which gives us a negative cash balance for the day. What happens if we do a day that we know we don't have any transactions? Well, it behaves as we expect, so that's good. It tells us that we didn't do anything on that day. Okay, so this is going to sum up the screencast. We've essentially shown different ways you can work with Python, the interpreter, to insert data into a database, access that database, and then finally building in some logic for working with the results from that database that you wouldn't necessarily want to do just using an SQL type language. So that concludes the screencast. Hello. So today we're going to be talking about how to work with messy data and to use Python to clean up some of the mess and turn that data into something that can be read into a database and stored in a database in a more structured, nice way. So in the video lecture, we've already talked a bit about some examples of how you might want to do this. Some forms of messy data include dates coming through in formats you're not used to dealing with, quoting issues, this kind of thing. But today we'll work with a different example that has its own sets of quirks. And so this example is shown on the screen now. It is from the U.S. Census. It is a CSV file which shows the population of cities in the U.S. with a population of 50,000 or more, and it includes the 2010 census count along with estimates for, in this case, 2011. So we're going to try to work with this, take this data, take selected columns out of here and put it into a database. And when you look at this data, just looking on this website here, we can see that there's already some strange things. Like looking here at the top, the first couple lines here, just free-form text, table with row headers and column A, and so all this stuff that's not really very good for us here. So things that aren't real data. So we can see here that the first two lines are not very useful. The third line is some measure of column names. So we're going to skip those first three lines and then continue on reading down. If we actually scroll down and check the bottom, we can also see that there's also some strange things going on at the bottom. After we pass the Soto Texas, then we'll see that there's this big long legalese note and clarification stuff. So we know we also don't want these last steps either. So that's a problem. And looking in here, we can see certain things that we like. So the ranking for the city, that seems like we want that. When we look at these cities, they sort of have this weird thing going on where, like Watsonville City, California, or on line 692, Buckeye Town, Arizona. So we'd like to get rid of this town thing or village or city distinction and just try to get the name of the city or town or village. So that's something we're going to deal with. And the last issue that I can see just from looking around is look at these numbers. We can see that the population estimates have commas inside them. That's why they've got quotes escaping them because so this is going to be read in its default as a text and a string, which is not what we want. We actually want the resulting number. So we're going to need to do a bit of cleanup to remove those commas so that we can actually reason about this in the sizes of the cities for our data. Okay, so this process here I just kind of described to you is what you'll need to do every time you get a new data set. You want to look at it and just see it. Are there quirks to it that you're going to need to be able to clean up? So do you have a strange formatted date? Do you have commas in places that you don't need commas? Do you have header and footer information that just needs to be thrown out? This kind of stuff. So there are other things that can go wrong too, but this gives you a pretty good sample. So given this data set, what we're going to do in the screencast today is explain how we can go through here and use Python to clean this up before we put it into our database. So now I'm going to bring up the Python code, and I will also bring up a terminal window. We'll Python. I didn't paste that in, so let's go here. Make this a little bigger. So we've got a Python interpreter. We have a database that we want to create. And so I've sort of copied in here a little string in my Python file to remind me of what the data I'm looking at, what it looks like. So we have the ranking information, these extra appended cities, and things like the commas. So we're going to start by creating a connection to an SQLite database, and we're going to save that into file location city pop.db. And I decided, okay, given this structure for the CSV file, what do we actually want? And so I figured we were interested in the city, state, the ranking, so that this is the ranking in terms of the population. And then we've got a bunch of population numbers, but I think the only thing I really care about is the census population and then the estimate for the population in 2011. So we will create a command here that's going to actually build a table. If we didn't have a syntax error, that is. Let's see here. Did I screw up? That's probably good. Okay, so I found the bug. You have to be sure to actually name your table something. So we're actually going to call this city pop. So that's why we're getting syntax error. So fortunately, running this in the interpreter will give us this feedback immediately. So now we then execute this command with a named table, and that executes correctly. And what are we going to do? We will end up constructing a query where we're going to insert into this table 5 values for city, state, rank, and the 2 populations. Then what we want to do is we want to actually connect to the CSV file that I showed you in the browser previously, so we provide the URL for that. And then we're going to do a couple things. First things first, because we're working in the interpreter, I want to just look at some of the first few lines of the CSV file. So I can kind of work with the data that comes out to see what I actually need to do for going through this systematically. So I'll start by running this code here that I've created. So I'm going to build the CSV reader onto that file. URL location I listed, and then I'm going to go through and check through the rows. I'm going to skip the first 3 because, as we saw in the overview, those are not useful data points. And then we're going to print out some rows. We're going to stop after we get through line 10. So I just want to see a few print on the screen so I can work with them. So if we do that, we say, all right, we have the place, state, census, blah, blah, blah. Okay, so we can see a few things. One is we can see that it seems as though we actually need to skip 4 lines and not so much 5, because that 4th line here actually corresponds to place, state, and census. So those are the header values. So we can see these other rows looks a bit like the following, where we have everything comes in as a string, but we've got our numbers with commas and we've got these extra city things. So by typing the interpreter, we get, so this last row we encountered, Phoenix City. That one is currently assigned to the row variable. So this gives us sort of an insight as to what, when we're working through this for loop, what the intermediate variables can take on. So what do we actually want out of here? Well, one of the first things we want to do is we want to get rid of this city thing, okay? So we can use something in Python called split, where we know that we were interested in just working in the city. So we say row of 1, so that tells me that gives us a string Phoenix City. Now the split command, you provide a string like row 1, we say split, and we're just going to split based upon, we're going to split up the string into a list of strings based upon every encounter of this delimiter. In this case, the delimiter is going to be space. So if I split that out, I say Phoenix and city. And so what I actually want to do is I want to get rid of that city. I'm going to strike it out. But I want to write this in a general way so that whenever I encounter villages and towns below and towards the bottom of the CSV file, I'll remove those as well. So what I really want is all the elements of this list except for the very last one. So something like that, like Phoenix. Now, if we had a different example, like Los Angeles, which is a 2-word city, we would know if we had the c.split and took up through the last one. The difference is now we have a 2-element list. So basically, we've got all the words that we want. We just need to turn it back into a string. So to do that, what we can do is, we're just sticking with Los Angeles for now. So we take this, we can use the sort of inverse to split, which is something called join. And so you have the string you want to be your delimiter, and then you call the join method built into that string. And voila, what we have here is a rejoined string with the same delimiters and spaces, but we've dropped off the very last word. Okay, so we want to do that for all of the row 1 items through this list. So we end up doing, all right, so that gives us Phoenix in this other case. So we can actually end up assigning this to a variable called city, and then we'll copy and paste this back into our, will ultimately be our main for loop right here. Okay, so if we look at the code that we have presented here, looking on line 56 of the getCityDate.py file, we have our file where we're going to open up the URL location, and then we're going to go through and look through using the CSV reader object and get one row at a time. We know we actually want to skip the first 4 lines because if we look back at our printed example over here, we can see that we still had a header involved, which is not good. And then the next thing we want to do is we want to deal with this problem of what you do with the trailing end of the file. Because if you remember, if you look back at the file, you'll see that after DeSoto, we end up with all these things in notes. So I think what we can do is we can say, all right, if this first element here of the row, if you cannot turn this into an integer, then you know that you're not really interested in that row because it's not a city with a rank. So what we can do is we can turn this into a little try except clause where we try to calculate the rank value as an int of the first entry in row. So if we were to copy this line and put it in here, then what would happen is we would see that rank comes back. Well, Phoenix is the 6th largest city. Whereas if we try that on if we were to try the same thing on a string, like food is tasty or whatever we have, that's going to give us a value error. So we're going to catch that error whenever we get to a non-city entry, and then just ignore it. Okay, so that's how we deal with the issues at the bottom of the file. So then we go back to our row here. We're going to take out the city appended to the end of each place name or town or village, whatever it is. So that's what that line does. So we're in pretty good shape there. Fortunately, there's nothing we need to do for states because those all seem to be pretty well formed. So we can just assign state gets the second element of the list. In Python always counts from 0, so it's a 0, 1, 2 entry. Okay, so then we can deal with sort of our last main issue is how do we deal with these commas in our numbers, right? Because if you were to just try to take, say, these 0, 1, 2, 3, 4th entry here and turn row of 4, it's going to give us a value error again because see, look, we've got these commas in here, so Python doesn't know how to deal with it. So we're going to have to use the split command we had previously used. So if we were to say row of 4.split, then we'll see that, so this 1,445,656 gets turned into a 3-element list. Well, we can undo that right away by doing a join. In this case, we're joining together with nothing. So we end up with a string now that is just numbers. So we can then turn that into an integer quite easily using the casting method of an int. Okay, so we're going to do exactly this for getting the population estimates for 2010. So census 2010 gets assigned that there. Because it's actually the 3rd element, excuse me. And then we do the same basic thing for the 4th, 5th, 6th element of the row. And we'll see that in the case of Phoenix, the population estimate by 2011 jumps to 1.469 million. So essentially, we can take this back to our for loop where we've sort of gone through and gotten each of the entries out of each row of the CSV file, formatted in a way that we're happy with, and then assign them to local variables. And we just put the local variables into a tuple that we then execute the query on. So if you recall, our query is just this string where we're going to insert into the city pop table these values with these 5 values. So our final step here is to execute this command with the query and give the tuple with each of the values that we've assigned: city, state, rank, and the 2 population values. And this whole thing again goes into this for loop. So we're going to step by step go through this process. We read each line. We have these checks to make sure we're not at the beginning or end. And provided that we're not, we can compute the rank, city, state, and these population values, and we'll just execute them together. So if I copy this whole thing and put it into the command line, we get an error. Okay, so how can we debug this error? String object has no attribute execute. This is because I was being foolish earlier on, and you'll see that I actually assigned Los Angeles City string assigned to a temporary variable C. So I ended up overriding our cursor from before. So we actually need to reassign that. So I ended up reassigning the value for C, and now when we execute this, this should work, and it worked for quite a long time until we got sort of towards this bottom point here. So what does row look like in this case? Oh, row is a X. So this is an example of your data continuing to be messy. So we have an attempt to turn what is not a number into this value here. So how should we deal with this? Well, what we should do is whenever we can modify our code to actually deal with this problem. So we're going to try, and we'll have an except value error, and then we'll say, okay, in this case, census 2010 ends up being, we'll give it a value like -1 because it's not a valid entry. And then we'll do the same thing in case it happens on our later estimate, where if we're unable to turn that into something useful, we'll assign it to this value here. Okay, so if we try this one more time, where now it seems to have worked okay. We finished by committing and closing our cursor, and we should now have a nice, clean database that we can actually work with. So Python in review is really good for dealing with messy data. And the important thing is that you work with an interpreter like I was doing here, because you can find new problems with your data as you go along, like that X we found there at the end. So you'll come to find from working with, as you work with more data, that there are sort of some standard problems that crop up, things like commas in your numbers, missing value entries like that X, strange dates. And so as you get more experience working with them and being comfortable with dealing with them in Python, you'll be in much better shape for putting process data into a workable database. So that concludes our screencast for dealing with messy data.